Hey, Algebra 1 students, we're working on section 1.8 and we're going to talk about graphs and functions. Our vocabulary is kind of extensive, so we're going to make a point to actually make sure we get to all these words, but we're going to do it somewhat out of order. We're going to actually start with the concept of coordinate system, and a coordinate system refers to plotting things on the coordinate plane, this x and y axis plane. And so the first term that I want to talk about here is to highlight the x-axis, which is the horizontal axis that goes from left to right. The next term is the y-axis, and that goes from north to south, or the vertical axis up and down. Let me use red to highlight that. It's a little bit more distinctive. And so that's my y-axis. The point in the center, this point right here, is referred to as the origin. That's the origin. And the ordered pair that's associated with the origin is 0, 0, because you go to 0 on the x-axis and 0 on the y-axis to find it. Ordered pairs refer to the way that any point on this coordinate plane or within this coordinate system is named. So if I had, for instance, a point here, let's call it point A, this has an ordered pair that is associated with it. So what we do when we name an ordered pair is we first figure out the x term. This x value would be 4, and the y location would be 3. This numbering looks a little bit off, but I hope that you see that this 1 refers to this part, and this 2 refers to this part, 3 refers to this part, 4 refers to this part. All right, hopefully that makes sense. Let's get rid of that. So the ordered pair associated with the point A is 4, 3. And I'm going to highlight that one so we recognize that ordered pair, this is an example of an ordered pair, and this is an example of an ordered pair. So what makes up an ordered pair? Glad you asked. It has an x-coordinate and a y-coordinate. So the x-coordinate is the first coordinate in an ordered pair. So the x-coordinate is this guy here, or this guy here, and the y-coordinate, second coordinate value, is going to be here. Notice that x comes before y in the alphabet. That's one way you can keep track of which coordinate is going to come first. Now, when you think about this idea of the independent variable, short information is that generally when we talk about the independent variable, we're talking about x. So generally we're talking about the x value. So generally if you're graphing an independent variable, you're talking about what you're going to be graphing on the horizontal line, and the dependent is the y variable. I know that doesn't really describe exactly what it is. In words, an independent variable is the variable that doesn't vary, that doesn't change because of another variable. That's still a terrible definition as well. But we're going to go with that until we see like a situation. And when we have word problems, it's a little bit clearer and easier to explain. So x doesn't depend on y. Y's value generally depends on x. So when something depends on another variable, whether it's how much money you get because of the hours you worked, right? So money would be the dependent, hours would be the independent. You'll see that relationship. So we'll discuss a little bit. Okay, so the real challenge, not really of a challenge, but the definition of a relation, I think, should come before a function. So that's what I'm going to talk about. So here's a representation of a mapping that I'm going to have, of a relation that I'll have. Like I can associate the number 3 with 5, 4 with 2, 7 with 6, and maybe even 4 with 8. This is a relation. It just shows a relationship between two sets of numbers. Relations can be between anything: people, chickens, scarves, and a scarf and a person, a birthday and I don't know, anything. But because we're talking about math, we're going to have our relations dealing with numbers. So I'm going to just stick to this definition right quick. And so basically a relation is an association of numbers with other numbers. in math, okay? And so how they're associated is kind of the rule of the relation. So in this case, I could make up any situation and say, on the third day, I spent 5 hours doing math. On the fourth day, I spent 2 hours doing math. But then later on, I spent another 8 hours doing math. And on the seventh day, I spent 6 hours doing math. I don't know, just making stuff up. So this is referred to as a relation, just this association. And I could show a relation as a mapping, as I've done this here. I could show a relation as a table, right? And my table, what did I say? The day and the number of hours doing math, right? I can do something like this. So I get like 3 and 5, 4 and 2, but 4 is also associated with 8, and then 7 and 6. All right, so this is a table relation that I can show a relation. I could also show a relation as ordered pairs. So 3, 5, ordered pair 3, 5, 4, 2, 4, 8, and another one 7, 6. So this is 3 different ways to represent a relation, and hopefully you're probably thinking, well, you could plot those points, lady, and indeed I could. And so there's 4 different ways to represent a relation. So a relation is just an association of 2 numbers or 2 amounts, as we have here. Now, a function is a specific type of relation. This type of relation is such that we have exactly one of these guys only goes to one of these guys. So you see how 3 goes to only 5 and 7 goes to only 6? If those were the only 2 elements in my relation, I'd be cool. But now that I've got 4 that goes to 2 and to 8, this relation fails to be a function. So functions are relations where each member of this first set is only met to exactly one member of this other set. Now, me saying this set and that set doesn't help, so let me give further into our definition pool. This word domain refers to this set of numbers. The first set, or the independent variables, right? All of this stuff is coming together, or the x's. The domain is the numbers that I'm mapping onto another set of numbers. So 3, 4, 7 would be the domain, and the range, let me do a little arrow here, and the range would be this other part, 2, 5, 8, 2, 5, 6, 8 would be the domain, would be the range. I'm sorry. So the domain goes to the range. So here the domain is here, the range is here. The domain refers to the set of all x values, and the range refers to the set of all y values. And so now I can give you a better definition of function. Now that I've got all this stuff out of the way. A function is a relation, I'll write it here. A function is a relation where each member of the domain is mapped to exactly one member of the range, or is associated with exactly one member of the range. And I know this is a bit of a convoluted definition. It'll make better sense later, but let me give you an example of a clear functional relationship. So my favorite example to use with students is birthdays. So if I list a bunch of friends, like my friend Lisa, these are not real people, by the way, my friend Andy, my friend Sam, and my friend, I don't know, Sally. All right. Yeah, I spelled Sally like that. All right. If I map each of these people to their birthday, Lisa's birthday, again, made up people, is August 4th. Andy's birthday is September 9th. Sam's birthday is January 7th. And Sally's birthday is December 23rd. So if this is a relationship, right? This is a relationship where each person is being mapped to their birthday. My domain contains all these people, and my range contains their birthdays. Pretty cool, right? Okay, now this is a function because each person has exactly one birthday. One person will not have 2 birthdays. If they did, that would be illegal, right? if you had two birthdays, because it's impossible. I know, think about it. For years, people say, well, what if you were born at midnight? You still have one birthday, pumpkin. All right, so you have one birthday. Everybody has one birthday. So each member of my domain is mapped to one member of the range, and therefore I have a function here. And so I know what somebody's thinking. Somebody's saying, but wait a minute, other people can have that same birthday, and so what you're talking about doesn't make sense. Yes, you're right. So we could add somebody else to our situation, to our domain, and that's Lily. Lily has a twin sister, Lisa, and their birthdays on the same day. You see where I'm going? You see where I'm going with this, right? But this is still totally cool because, again, one person doesn't have two birthdays. One person has one birthday. And so this is my little like way to remember what an actual function is. A function is a relation where each member of the domain is mapped to exactly one member of the range. Even if other things are mapped to that member, you can only be mapped to one thing, just like you can have only one birthday. Woo, that was a long discussion. Let's try to get a couple examples in. I think this is going to be a two-part video. Let's check out example one. Okay, so here we have with identifying coordinates. This should be right on point with you. So let's see, sports medicine. Refer to the application above. So they had an application. I'll use this picture. Name the ordered pair at C and explain what it represents. So we go over to C and we could see that C is at 2. And here's 75%. C is a little bit above 75%. And so I'd say it's like, I don't know, 78, something like that. So sometimes when you're dealing with a real life situation and real life graphs, you have to approximate the value, but I feel confident saying that that's about 78. So this ordered pair is going to be 2, 78%. And now we need to explain what it means. Well, that was the easy part. The hard part is to basically make sure you understand what's going on. So here we're talking about blood flow after a concussion. And so this is 1, 2, 3, 4, 5, 6, 7, 8, 8 days after a concussion. And this is the percent of blood flow, I suppose, in the brain. So we have to explain what C means. So it looks like C represents that after 2 days after a concussion, you have 78% blood flow, can I say that? Blood flow in the brain. 2 days after a concussion, 78% of blood flow is expected. All right, let's take a look at another example. Here in example 2, we're going to be talking about independent and dependent variables. So we're going to identify the independent and dependent variables for each function. So here's a relationship we're going to talk about. In general, the average price of gasoline slowly and steadily increases throughout the year. So we've got two quantities that we're talking about, or two amounts, and one clearly is the price of gasoline. And so the price of gasoline is the thing that we're talking about. We know that it slowly and steadily increases. But what's the other quantity that we're dealing with? The other numerical quantity. And this one's a little bit hard to realize, but it's throughout the year. So as the days of the year go on, the price of gasoline increases. Which one is the independent variable and which one is the dependent variable? Well, the price of gasoline depends on the day, but the day doesn't depend on the price of gasoline. So the price of gasoline is the dependent variable, where the days throughout the year would be the independent variable. So the next thing we'll do is consider the profit that a business makes generally increases as the price of their product increases. This one's a little bit trickier, but what's increasing? The profit increases as the price increases. So which one depends on the other one? Let's talk about the two that we have. So one variable that we're dealing with is the profit that a business makes. And the other variable that we're dealing with is generally increases as the price increases. So the price of their product is the other variable. So which one is dependent and which one is dependent, which one's independent? Hopefully you see that the profit is going to definitely depend on the price. So this guy is the dependent variable, and here we have the independent variable. All right, so with that in mind, we're going to look at the next examples in another video. So let's go ahead and talk to me in a few minutes when you go ahead and take a look at the next video.